Okay, this is a classic instantaneous velocity question at the beginning of calculus 1. This is what we have. Suppose we have a ball that's thrown into the air, like the ball like this, and we have an initial velocity of 40 feet per second, and we know that the height after t seconds is given by this equation, and we are going to find the velocity when t is equal to 2. Notice if it says velocity at a t value, that means the instantaneous velocity, and this is all we have to do. First off, I'm just going to write down phi of t to represent the instantaneous velocity when t is at 2. Well, I will take the limit, because remember, the instantaneous velocity is going to be the limit of the average velocity, but we just have to make sure that the t is approaching 2. And right here, let me just call this to be our function, and I'm just going to write it down as y of t, because we have y and it's a function of time, so we will use this notation. Right here, we need to do y of t minus y of 2. Yeah, and then divided by t minus 2. Yep, this is just the derivative formula, right, with the limit definition, and that's also the slope of the tangent line. So yeah, you have a few ways to interpret this. And now we just have to compute this. So let's go ahead and write down this again. The limit as t approaches 2. Y of t stat, which is 40t minus 16t squared, and we will have to minus y of 2. So let's go ahead and do it on the side. Y of 2 is just that we put 2 into this t and that t. So y of 2 is equal to 16. And then all divided by t minus 2, like that. Cool. And you know it, this is going to give you 0 over 0 because that's how it's set out to be. So we will have to do some work for this. We're going to factor things out on the top and then cancel things out, right? And let me just write down the limit as t goes to 2 again. And right here, let me just factor out, because we have 40 minus 16 and minus 16, right? Let's factor out negative 8, because we like to have this term to be positive. And let's write down the square term first. Originally, we have negative 16, but we took out negative 8. You can just divide. Negative 16 divided by negative 8 is positive 2. And then this is the t squared term. Next, originally we have 40t, we divided by negative 8, so that's going to be minus 5t. And lastly, same thing, we get positive 2. And all divided by t minus 2. Now, this part is a trinomial that we have to factor. Let's go ahead and do it on the side. 2t squared minus 5t plus 2. I will use the tic-tac-toe method for you guys. Let's go ahead and draw the tic-tac-toe boxes, like so. Well, we need 2t times t. That's how we can get 2t squared. And to get the negative, that's the answer. To get the positive 2, we need negative 1 and negative 2. I'm going to put negative 2 here and negative 1 here, because this times this will give us, negative 4t, and then this times this will give us negative t. And you see, this and that combined to be negative 5t, so we have the correct combination. But remember, to read this for the answer, we go across. So the first factor is 2t minus 1. So let me put it down on the top right here. And then the second factor is t minus 2. Alright, and now, as we can see, this and that cancel each other out. So in the end, we just have to put the 2 into this t, and don't forget we still have this minus 8 here. So we will have, this is 3 times negative 8, we get negative 24. Alright, and remember, this is an application question, so we should include the unit for the final answer. And this is a velocity, and the unit for that is feet per second. So I'll just put down ft per second like this. The velocity is negative because the ball is actually going downward. Okay, another displacement and velocity question. This time our position function is this. S is equal to 1 over t squared, and we are going to find the velocity when t is equal to a, and then t is equal to 1, 2, and 3. And the idea of using this right here is so that we can come with a formula, and then we can just plug in 1, 2, 3 into the formula and then compute the value. I'm going to write down phi of a, meaning the velocity when t is equal to a. This right here is given by the limit as t goes to a, and then right here, this is our position function. I'm going to write this down as s of t, and then minus, well, position at a. So we will have s of a, and then divided by t minus a. So that's the setup, right? The slope of the tangent line, the derivative, all that good stuff. All right, so let's plug in and then just compute the limit. Here we are going to get the limit as t goes to a. S of t is just 1 over t squared, that's good. Minus 1 over, well, just put a in here, so we have a squared here. So that will give us s of a. And then on the bottom, we still have the t minus a. Okay, how can we simplify this though? Well, I would not suggest you to factor this out yet. We should clear the complex fraction first before we do any cancellations. So what we will do is, let's multiply the top and bottom by this and that, so we can get rid of the complex fractions, meaning the small fractions on the top. So let's multiply the top and bottom by a squared and t squared, like so. And we are going to just distribute. But before that, remember to write this down again. So I'm going to write down the limit as t goes to a. All right, take this times that, the t squared will cancel. We will just have a squared right here. And then minus, next a squared will cancel. So we will just have t squared. And then on the bottom, I'm just going to keep it as how it is, but I'll write this down first. A squared t squared times t minus a. Alright, the top is a difference of two squares, so we can factor it, and we will get parentheses a minus t times a plus t. Good. But be really careful now. Notice this is a minus t and this is t minus a. They are almost the same. So what can we do? Well, we are just going to change the order of subtraction, but we will have to negate the result. So for this part in particular, this is going to be negative parentheses and then just change the order of subtraction, t minus a, like this. Okay? And then in fact, here, if you want to change the order of addition, doesn't matter. So you can write it down as a plus t or t plus a, doesn't matter. I'm just going to keep it as how it is. And now we can cancel. So what we have is the following. The limit as t goes to a. Actually, let's just go ahead and plug in the a already because we canceled it out already. So let's put the a into this t. So on the top we get negative, and then we have this a plus the t. Again, we plug in a into the t. So we have the a here, and then divided by a squared, still a squared. But we put the a into the t, so we have another a squared right here. All right, and now let's just clean things up from here. On the top, a plus a is just 2a, and that's negative, so negative 2a over, this is a to the fourth power. And we can reduce this because this is the a to the first power, so cancel, and this will become 3. So finally, we get negative 2 over a to the third power. So this right here will be the velocity of the moving particle when t is at a second. And right here, we should technically put down the unit, so we will, which is meters per second. So I'll just put down m/s, like so. Cool. And now, don't worry, we do not have to do a limit definition like 3 more times, because we have this as a formula. So once we know phi of a is equal to that, phi of 1 is just going to be nice and easy. Put a 1 in here, we get negative 2 over 1 to the third power, which is just negative 2. And then put a unit, meter per second. Done. Yeah. Next, phi of 2. This right here is equal to negative 2 over 2 to the third power. That's equal to 8. So we will have negative 1 over 4. Again, meters per second. And then we are done for that. And lastly, phi of 3 equals negative 2 over 3 to the third power. Cannot simplify anything. I'll just keep it as how it is. Negative 2 over, well, work this out, right? Of course, it's not 9. 3 to the third power is 27. I don't know why I almost thought about it's 9, but no. Anyway, meters per second. All right? That's it.